Priya found the discrepancy at 11:47 on a Wednesday night, which was the kind of hour when small errors become large ones because you're too tired to dismiss them. She was checking her own work, a habit from graduate school that had never left her, the last pass before submission, the verification that what you calculated matched what you expected. The data set was from a survey telescope, 18 months of observations of type 1a supernovae across a redshift range that should, by every model she trusted, produce a clean, consistent measurement of how fast the universe was expanding. The number was wrong. Not wildly wrong, not the kind of wrong that signals a corrupted file or a unit error. The kind of wrong that is just slightly outside the boundary of what's acceptable. 3 sigma, which in most contexts means probably noise, but in a data set this clean and this large meant something else. Something she could not immediately name. She wrote it down on paper. Old habit. Writing made things more real and also more containable. Then she checked the pipeline. The reduction steps, the calibration, the photometry, everything looked correct. She checked the input catalog against the published coordinates. Every source matched. She recalculated the distance moduli by hand for 6 of the supernovae, choosing them at random, and got the same answer the pipeline had given her. The number was still wrong. She leaned back in her chair and looked at the ceiling. The lab was empty. It was a university building, and most people had gone home at a civilized hour. The ventilation system made a sound like a river at low water. She had worked in this building for 6 years, and she had stopped hearing that sound about 5.5 years ago. But tonight she heard it. She thought about what 3 sigma meant. If it was not noise, it meant the universe was expanding faster than the best models said it should be. It meant dark energy, the term cosmologists used for the unknown force accelerating that expansion, was behaving differently than they had described it. It meant either her data was wrong, or the model was wrong, or both, or something else entirely that she didn't have language for yet. She emailed her collaborator James with the subject line, "Look at this when you wake up. Don't panic yet." Then she closed her laptop and went home and lay awake, thinking about a number that was 3 units from where it should have been. In a universe so large that 3 units could mean the difference between a cosmological constant and a catastrophe. James called at 7 the next morning. "Tell me it's a systematic," he said. "I can't," she said. "I looked." Silence on the line. "I'll be there in an hour," he said. James arrived with coffee he had bought for himself and forgotten to offer, which was how Priya knew he was genuinely rattled. In 6 years of collaboration, she had never seen him forget coffee. They spent 4 hours going through the data together. James was meticulous in a way that was almost punishing to watch. He questioned every assumption, every input parameter, every step in the reduction chain. Priya had done this alone the night before, but doing it with another pair of eyes was different. James caught 2 things she had missed. Neither of them changed the number. At noon, they sat across from each other at her desk and looked at the result. "We need an independent check," James said. "I know. The Hubble data from last cycle, I already requested it." She paused. "It'll take a week to come through." James leaned back. He was 53, older than Priya by 15 years, and he had the quality of stillness that came from having been in this field long enough to have seen results that reversed and results that didn't. She watched him decide how worried to be. "The tension was already there," he said finally, "before our data, the Hubble constant tension, the gap between early universe measurements and late universe measurements." "This makes the gap wider," Priya said. "By how much?" She showed him. He looked at the number for a long time. "If this holds up," he said. "I know. This isn't a small adjustment." "I know, James." He stood up and went to the window. Outside was a campus quad, students crossing it with the particular unhurried movement of people who did not know that in a small office nearby, 2 researchers were looking at data that suggested the standard model of cosmology might need to be reopened. "We don't say anything yet," James said. "We wait for the independent check. We look for every possible systematic we haven't considered. We go back to the raw data." "Agreed," Priya said. "And we don't talk about it." She looked at him. "Not even to the group?" He turned from the window. Who in the group would not talk about it? She thought through their 8 colleagues. 3 of them would post about it on social media within 48 hours. She did not say this because she didn't need to. 2 weeks, James said. We work quietly for 2 weeks, then we assess. That evening, Priya went back to the lab alone. She pulled up the literature on dark energy, not the introductory material, the hard papers, the ones arguing about whether the cosmological constant was truly constant or whether it varied with time. There was a parameter called W, the equation of state of dark energy, which was supposed to equal -1 if dark energy was a simple vacuum energy. If W deviated from -1, dark energy was something more complicated, something dynamic, something that changed. Her data, if correct, implied a deviation. She sat with that word for a while. Dynamic. A universe in which the force tearing space apart was not a fixed property of empty space, but something alive and varying, something that had a history and perhaps a future different from what any model predicted. She did not sleep well for the second night in a row. This time it was not one discrepancy. She lay awake thinking about it was what the discrepancy would mean if it was real, and the particular vertigo of standing at the edge of something very large and not yet knowing whether you were about to fall or fly. The independent data arrived in 9 days, not 7. The Hubble Space Telescope data came through on a Thursday, and Priya processed it immediately, and it took her until Saturday to check it well enough that she trusted the result. The result confirmed her measurement. Then she sent it back with a note that said, "I think we have to bring in the group." He replied within minutes, "I think you're right. Schedule Monday." She sat with her hands on the keyboard for a moment. Once they told the group, it would move outward. Colleagues who would check the work and find their own concerns, which would require answers, which would generate further questions. The thing would grow until it was either killed by a systematic nobody had found yet, or it would survive and become a paper, and then other groups would try to reproduce it, and either would or wouldn't. It was a process she had been through before on smaller results. This was not smaller. She scheduled Monday and then spent Sunday reading everything ever written about dynamic dark energy, phantom energy, quintessence, the names theorists had given to the possibilities that lived outside the standard model. She read until she understood the landscape, or as close to it as a person could get in a single day. None of the models predicted exactly what she was seeing, which was either because her result was wrong or because the right model had not been written yet. One of those was frightening. The other was something else. She could not yet tell which one she was holding. Monday morning, 8 researchers in a conference room with bad lighting and a projector that took 4 minutes to connect. Priya presented for 45 minutes. She went through the data, the pipeline, the independent confirmation, the systematic checks, the corrections applied, the residual discrepancy. She did not editorialize. She showed what she had and described what it implied. When she finished, the room was quiet in the particular way of people who have questions but are selecting which one to ask first. Marco spoke first. He was a postdoc, 29, and his instinct was always to find the error, because finding errors was how you established yourself in this field. He asked about the photometric calibration in the reddest band. She had the answer ready. He asked a follow-up. She had that too. He sat back. Then Yuki, who was careful and systematic and had been in the field longer than anyone except James. She asked about the redshift distribution, whether there was a bias toward high redshift supernovae in the sample that could introduce a Malmquist bias. Priya had checked this. She showed the distribution. Yuki looked at it for a long time. "The distribution looks clean," Yuki said slowly. "But clean data with a consistent offset is more concerning than noisy data, not less." "I know," Priya said, "because a systematic that perfectly mimics a signal is harder to find than random noise." "Yes." Yuki nodded and said nothing further. The questions continued for an hour. Some were hostile in the professional sense, pointing at weaknesses, demanding justification, and some were genuinely exploratory, following the implications. James sat at the back and said almost nothing, which meant he was either worried or thinking. With James, it was difficult to distinguish. At the end, Marco said what everyone was thinking. "If this is real..." "We don't know if it's real," Priya said. "If it is," he continued, "this isn't a refinement of the existing picture. This is a structural problem." "Yes," she said. Dark energy is varying with time, or something we don't have a name for is doing something we didn't predict. That's a reasonable summary. How do we rule out the alternative interpretations? She had a list. She had spent 3 weeks assembling it. She handed out copies, a 2-page document with 18 items, each one a test that could be performed, an observation that could be made, a calculation that could address a specific alternative. The group read it. James spoke for the first time. This is the work for the next 6 months, he said. We go through this list. We don't write anything yet. We don't talk to anyone outside this room. He paused. If we get through this list and the signal survives, we submit. Priya looked at him. And if the signal doesn't survive, then we publish the null result and explain what we found and why it didn't hold up. He looked around the room. Either way we publish, the data is good data. The question is what it means. The meeting ended. People filed out carrying the 2-page list. If other groups confirm it, if this is what it looks like, he paused. We're not looking at a refinement, we're looking at a new phase. Dark energy is changing over cosmic time. The universe is not just expanding, it's changing how it expands. Whatever drove the original acceleration is evolving. Yes, Priya said, and we don't know what that means for the future. Whether the expansion will keep accelerating, whether it will plateau, whether something else is coming that none of the models have predicted. Correct. Correct. James was quiet for a moment. That's a lot to not know. It is, she said. It also means there's a lot left to figure out. He nodded slowly. I remember when I was a student, he said, before dark energy was discovered. Before 1998, we thought the expansion was decelerating. Gravity was going to slow it down, maybe reverse it. The universe was going to collapse eventually. And then the supernova data came in and showed us we had the direction wrong, not decelerating, accelerating. And every calculation we'd done for the future became obsolete overnight. He looked at her. That's happened before. It can happen again. I think it's happening again, Priya said. What do you think is causing it? The variation. She had been thinking about this for 6 months, reading the theoretical papers, following the arguments between physicists who worked on the problem from different directions. She had ideas. They were tentative, and she held them loosely. Something in the vacuum, she said. Something that isn't fixed. Energy that has a field structure, that evolves the way fields evolve, with dynamics we haven't measured directly before. She paused. Or something we don't have a name for yet. We've been here before. We name things after we understand them. James left. She sat alone. The paper would go live at midnight. By morning, it would be on every cosmology group's reading list. By the following week, other groups would be looking at their own data with her measurement in mind. Some would try to reproduce it. Some would try to refute it. The process was impersonal and slow and exactly right. She thought about the universe, not abstractly, but specifically. The actual physical fact of space expanding in every direction, galaxies moving away from each other at rates that were not slowing down but speeding up, and now, according to her data, speeding up in a way that was not constant, that was changing, that had a history more complicated than anyone had accounted for. It was tearing itself apart gently, slowly, over time scales so large that a human life was not a rounding error, but something smaller, a single Planck time in comparison to the age of the process. And in the middle of this vast, indifferent expansion, a person had looked at light from dead stars across billions of light years and noticed a number that was 3 units from expectation and had not dismissed it. She wrote in her notebook, "The universe does not care whether its behavior is convenient for our models. It does what it does and waits for us to catch up." At midnight, her phone showed the email notification from the journal. The paper was live. She closed her notebook, turned off the desk lamp, walked out of the building into an ordinary night, cold, clear, the stars overhead in their familiar positions, each one moving away from every other one at speeds too slow for any human lifetime to register. She stood on the pavement and looked up for a moment, which she almost never did, because she spent so much time looking at representations of the sky that the sky itself could feel redundant. Tonight, it did not feel redundant. It felt like a question she had just made slightly more specific, in a field full of people who would spend their lives trying to answer it, none of whom would finish, but all of whom would advance the line by the small, careful, honest distance that one person could move it. That was enough. It was more than enough. She walked to her car. Behind her, the stars held their positions and said nothing, which was all they had ever done and all that was ever required of them. The number was in the literature now. Whatever it meant, it would be found.